In this video, we're going to try to determine whether or not this series converges or diverges. Anytime we see this exponential piece in there, our best bet is usually the ratio test. So we're going to try applying the ratio test to see what we can figure out. So the ratio test says we take the limit as k goes to infinity of a sub k plus 1 over a sub k, the absolute value of that ratio. So we're going to look at the limit as k goes to infinity. The absolute value is not going to make a big difference in this one. So let's just go ahead and we have k plus 1 over 2 to the k plus 1 over k over 2 to the k plus 1, excuse me. Now, first step here is going to be to flip and multiply. So a lot of times, you're not going to write this step or this step. You'll go right to this step as you get better with this test. K plus 1 over 2 to the k plus 1, so that's our a sub k, times 1 over, or the reciprocal of your a sub k. 2 to the k over k. Like I said, you'll see that quite a bit. And again, I don't have the absolute values anymore because this is always going to be positive, so I'm not concerned about that. So we need to see if we can simplify at all. So we have the limit as k goes to infinity. This can be rewritten. So I have k plus 1 over, this can be rewritten as 2 to the k times 2. And now I have 2 to the k over k. Those 2 to the k's are going to cancel. That 2 can be pulled out in front of the limit because it doesn't depend on k. Now it's in the denominator, so it's actually a 1/2 as being multiplied by the whole ratio. Limit as k goes to infinity of k plus 1 over k. One step below L'Hopital's rule very easily will show that this limit equals 1. So 1/2 times 1 equals 1/2, which is not equal to 1. So what we see is that we have a non-zero end result that is less than 1. So we can conclude that our series k over 2 to the k converges by the ratio test.